we should move on. So thank you very much for that. So who's going next, Nicole or Keilin? Okay, Keilin's next. Okay, cool.
All right, so I'll just share my screen here. Can everyone see that?
I think something's coming.
It's actually supposed to be a blank screen to start.
It is.
Yes. All right. Have you ever looked up at the dark night sky and wondered, wow, I wonder what's up there? Well, since the dawn of time, this has been a constant thought through human beings' minds. And humans have explored. They've explored lands, inventions, new ways of life, and space is no different. Good afternoon. My name is Keilin Morrison, and today I will be presenting to you on the future of space exploration. I will go through 3 hurdles that I really think space has in terms of what it has to do with astronauts, and I will also go through some of the inventions and research that is currently being done to alleviate these hurdles for astronauts. I will then go through a few of my own ideas of how the technological singularity and technological advancements can open the world up to space. Space is wildly intriguing and it's a very interesting place, but it is also very harmful. Technological advancements make this so exciting because space will not only become safer for astronauts, but it will also pave the way for members of the general public to experience space. So the 3 hurdles that I'll go over today are cosmic radiation, the effects of zero gravity, and mental health concerns. So to start off with, what do you think radiation is?
It's bad.
Yes, that's a good answer. So radiation is energy that comes from a source and travels through space and may be able to penetrate various materials. Now, I recently watched a documentary on Chernobyl, and as many of you probably know, this is arguably one of the worst nuclear disasters of our times. And it was just astounding to me to see how much of the damage that was done and how much of the radiation is still there. And unfortunately, this is not the same radiation that astronauts are subjected to, but they are still subjected to a lot of radiation, which is cosmic radiation. So some of the effects that radiation has on astronauts is that it impairs their spatial awareness, and it also affects their episodic and recognition memory. This was done on a study of rats, but it can have very similar effects in humans. Some other effects that radiation has on astronauts is that it contributes to reduction in spine density and reduction in the complexity of dendrites, which is the white matter in your brain. Furthermore, there were also changes to the neurons. So in terms of the neurons that handle behavior tasks. And this is very worrying for astronauts that have to perform experiments or menial tasks that contribute to their survival. Furthermore, the rats exposed to radiation had higher rates of fear and anxiety. Now, this environment wrought with radiation is highly detrimental to their health. And it brings up a very good ethical question. And I know a few of us really like ethics in this class. So the question is, should we continue to send human beings into such a damaging environment, knowing the drastic and lasting damage produced by cosmic radiation? What do you think?
I think it kind of depends on what the reason for doing so is. Like if there's potentially going to be a mass extinction because of the technological singularity on Earth, then if that's the only option for life, then that would outweigh a lot of other concerns potentially.
I mean, even beyond just the technological singularity, there's stuff happening here with climate change too. So if, again, like if it is a safer environment for us to be in some ways, like I'm the type of person where it's like, if I'm going, both are equally risky. So it's kind of up to you to just select one and kind of go with it. So yeah.
Thank you so much for your thoughts. So that brings me to my next hurdle, which is the second one of zero gravity environment. So by just by looking at this picture, it may seem really fun to, float around in zero gravity, but this environment too has very lasting effects on the brain, which I'll go over. So one of them is due to aging. Naturally, when we age, white matter in the brain deteriorates and it gets worn down. However, researchers have found that if we are in a zero gravity environment, this dramatically speeds up that process. Interestingly enough, it's not the amount of time you're in space for, but how many times you've been to space. So say an astronaut who has been to space for 10 times for an hour each time, probably not how long they spend in space, but let's just say that, versus someone who spends only 2 trips, but for 30 days. So the person that will be most affected is our first person who's been up multiple times, but for shorter lengths. So that was something I found very interesting. Another effect of the zero gravity environment is muscle atrophy. And this is due to the fact that in a zero gravity environment, you just don't have the same gravitational pull on Earth that you do on Earth. And it also contributes to changes in visual perception. So now let's look at some of the mental health concerns. And mental health is a very prominent topic, especially today with COVID-19. And so when we look at mental health, we're considering isolation and depression. Lots of astronauts are, well, all astronauts are at extreme distances from their loved ones. They are millions and millions of miles away, and they are also in confined spaces with the same crew. So that being said, it's critical to have good synergy. And a lot of the selection process for astronauts that we learned through Dr. Pandya was through, do they have a good synergy? Are they able to work in teams? However, when you're in such a confined space with the same people over an extended period of time, it's very easy to have group conflict. So let's look at the second factor, which is the importance of sleep in mental health. And some recent studies showed that low sleep was highly correlated to high stress levels. And furthermore, the people that were the most stressed on a flight contribute to 85% of the conflicts on board. In space, we also don't have a day-night cycle like that we do on Earth. They don't have the sun comes up, the sun comes down, when to sleep, when to wake up. They don't have that. So this contributes to abnormal sleep-wake cycles. And it also contributes to an unfortunate cycle of poor mental health. Furthermore, when we look at this picture of astronauts trying to sleep in space, we can see that they're being literally tied down to the side of the craft and with blinders on them. And personally for me, I don't think that would create the most optimal environment for sleeping. Now, there are pharmaceuticals that can help with sleeping, but this can also have very heavy ramifications and negative residual effects, like effects long-term on your liver. Now, furthermore, this one is looking a little deeper into the future of when or if we go to Mars. Now, from Dr. Pandya, we learned that there is a 6 to 46 minute delay between Mars and Earth. And this is significant, especially considering if there will be mental health emergencies or behavioral emergencies. So let's look at some of the positives. We're going to look at some promising research that has already been done and is underway on how we can solve some of these hurdles. So the first one is bioindicators, and these are looking for clues on emotional, social, and cognitive resilience. The goal with this one is to understand issues and identify coping methods for others to learn and implement in their life. And this can not only be used to help the individuals going into space, but it can be taken into a consideration by educators and fully and comprehensively rolled out to a large number of people. At first, for this graphic, I was going to use a picture that I found from the U of A lectures where it was in probably CSIS and it was a huge lecture theater, but I thought this would be a little more suiting for the times. So the next research that has been very prolific is resilience training. And these would be self-guided video modules on things like how to evaluate your heart rate and what it means, and also conflict resolution strategies. The goal with this one is to help address problems before they arise and also give avenues to mediate them. This next one is looking ahead as well. So if we go to Mars sometime, we will be in a situation where the Earth will be out of view. And for many, well, for all of us, this has never been the case. We've either been on Earth, in space, well, on Earth, in space, or on the moon. And so we've always been able to see Earth. However, on Mars, we won't be able to see Earth. It'll just be a tiny star in the sky, just like we see Venus. And so thinking ahead, one way to combat this Earth out of view phenomena is to have a virtual reality window installed on the craft that will simulate Earth. And this is a way to kind of trick the brain into thinking, oh, no, Earth is right there, and avoid some of those heavy psychological ramifications that we could see. So this is the fun part, and this is a part that I had a lot of fun coming up with. So technologies of the future. Now, just so everyone knows, these are not yet created, but I do think that they might have a lasting and positive effect on the future of space travel and will make space safer for astronauts and potentially for members of the general public as well. So going with our first hurdle of cosmic radiation, I envision a protective shield. I'm not sure what material or what metal it would be, but it could go over spacecrafts as well as space suits when the astronauts are going on their space rocks. Now, these suits and this protective shield would make it very difficult for cosmic rays to get through, and also slow down or more optimistically stop any alterations and effects to the human body that are caused by radiation. This next one is for our second hurdle, which is the zero gravity environment. And I actually discussed this one with another classmate, but essentially it is something called gravity pods. So when the technology first comes out, it would probably be quite expensive. And so they would probably only be available for an individual person. But this gravity pod would be the same gravity as found on Earth, and it would be installed inside an aircraft. So you'd have one gravity pod, everyone takes turns going in, kind of having a relaxing, kind of almost spa experience where you don't have the zero gravity, you're not floating around, and you have less effect on your muscles. And it will also try to stop the deterioration of white matter in the brain as well. So once it's on an individual level, eventually this could be rolled out on a group basis. So something like a living room situation where there's a designated room that's normal gravity. And then eventually this would be rolled out to the entire aircraft. So having something like this craft in space, but completely like it is on Earth. Now, I'm not sure how the physics of this would work or the specific mechanics, but it is an idea that I think could greatly help astronauts and the future space travelers. So, mental health, one of my favorite topics. And this slide is honestly inspired from Kim's talk a few days ago, and honestly throughout this course about his robotic dog. And so I think that even though this might not be a real dog, and as our guest lecturer today mentioned, he'd like a real dog, I think we all would, but I think it would be useful to improve the mental health of astronauts who want a sense of home, want a sense of companionship. And also, in my opinion, I think they're really cute. So one example could be Sony's Aibo, which would bring a sense of, togetherness and less stress on the aircraft as well. So this one is another thought in my mind, and it's to do with smart AI. So every day on the aircraft, a machine would collect self-evaluated surveys on things like mood, how you're feeling, and other parameters. The smart AI would then combine the data with observations on the individual's heart rate, their breathing rate, what they did in the past compared to what they're doing today. And from there, the AI would be able to draw insights into the individual's mental health state. Now, if someone is flagged for being at risk of a mental health crisis or just being at risk for poor mental health, the AI would then refer them to resources and support, as well as remind the crew that it is really important to take care of one another, especially when you're so far away from Earth, when you're under cosmic radiation, when you're in a zero gravity environment. There's so many stressors in space, and it's a team effort to take care of everyone. Now, this tech may seem out of this world, but with the technological singularity, I think that there is so much room for growth and beyond the technologies that I've conceived today. I'm excited because I really do think that with the technological singularity, technological advancements, space will become a more accessible place for astronauts and also paving the way for future generations. As Dr. Pandya alluded to in some of her lectures, as space becomes more accessible to people, it'll be really interesting to see what kind of art and inspiration members of the general public will be able to create after experiencing Earth. Now, Chris Hadfield, he's in the top right corner there. He is a prolific Canadian astronaut whose video Space Oddity went viral on YouTube. And this is just one example of how technology brought space a little closer to home. So if you were ever a kid longing to look up into the sky and wondering, I wonder what's out there. Well, maybe one day you can discover it too. Thank you. That's it.
It's a little weird when you conclude, right? Because it's like, and that's it. Yay. I liked that you touched on mental health. And I wonder if you have thought on how are we going to measure it?
Yeah.
Is it even measurable? Or is it something that has to be on a case by case thing? And I can give you a little bit of background on the research that I have done. I have read papers where they propose using a collection of different measuring mechanisms, if you will. We could measure molecules in saliva, and we could also use questionnaires to assess how a person is doing at any given time. So using these compendiums, we could evaluate whether or not a member of, in your case, the space team, needs, quick intervention. So did you come across any kind of suggestion on how to evaluate members in space?
Yeah, so that's a really good question. And I'm also very interested in mental health as well. One way that we could evaluate mental health is really looking at the before and after effects. So if this is like you're looking at evaluating the mental health right now, and with these new measures, has it improved? Has it stayed the same? Has it declined? And with the new AI that I've proposed or had a thought about, I think that as technology advances, we'll be able to pinpoint a little easier, okay, this is where the AI says your mental health is right now, and then it dropped a little bit, and oh no, we need resources. And so having some sort of graph eventually to chart individual mental health, I think will be very useful in the future.
Keilin, first off, this was a really good presentation. Thank you so much. I think there's a lot of really good information, and I think I learned a lot. I just kind of wanted to piggyback off of Eduardo's question about mental health, because that's also it's such a relevant topic and issue right now. And maybe you came across this in your readings for your research, but is there some sort of algorithm, or you mentioned AI in determining what, so if we're able to track and chart where individuals are struggling in their mental health, whether it's anxiety or depression, and there's so many different factors, right? Like, I think maybe there's a genetic component or a cultural, or maybe it's where you are in your life. Are you a university student, or are you a student who parents? Can we put all of that information and feed it into sort of AI machine learning algorithm to identify exactly what those points of information are, and then tailor sort of a course of action as afterwards? So, for example, if patient A or astronaut A is susceptible more to anxiety than someone else, they could be given a resource that tailors to them or their needs.
Yeah, that's a really good question. And I've definitely come across a few apps and a few research papers that look at that specifically. And I know there are some apps out there. There's there's Snap Clarity, there's a bunch of other ones that take data-driven. They take data, like you have to input a little survey, and then it takes that data and it tailors the responses directly towards you, which is, I think, really interesting. And I think it's probably like, I think there's always room for a human-centric approach, in that like going to see a psychologist is very, very helpful. But I do think that having an AI that just has like a daily reminder of, oh, like, I know that you're susceptible to these types of things at this part of the day, so here are some resources to help you get back from that. I think that in the future, it's going to be really interesting to see how advanced AI can get in helping people with their mental health, because I think, especially in COVID, when we're all isolated from each other, we are in a lockdown situation, that sort of thing, it's going to be very difficult for a lot of people coming up. It already is.
So I think that without AI, entertainment as a solution to mental health would fail miserably, right? Because everybody's different. And, you'd say, geez, we got all these things to do up there. And then they showed us these movies or, poetry or whatever. And that just made things worse, But with AI, they could deal with this extraordinary complexity of how everybody's different and figure out some pattern of entertainment to make mental health better overall and for each individual. But I think that's simply not accessible now. I think the music that astronauts listen to is quite random and relatively limited and so on. But, eventually there could be real science. Then people back home on Earth would get enthusiastic about various kinds of entertainment that had proven so successful in long distance space travel. Wow, that's really cool. This is what all the people going to, Jupiter listen to or whatever. Yeah. So I think that's something that will exist in the future, but not at all in the near term.
Just to jump in again, that the whole concept of like patient-centered healthcare, like Keilin, I think that's, you touched upon that, and that's such a huge part of this, because sometimes a physician or someone who sees someone struggling with mental health issues, if they're not like trained properly, if they're not a psychologist, they might just say like, hey, go do exercise, like it'll help your dopamine levels or your serotonin levels up. And that may work for some people, but for others that may not be the solution. It may be a deeper physiological effect. So I think having that sort of AI in helping in addressing where are actually the concerns, the points of concerns, the root of the issues, that could be a huge field of innovation.
Yeah, I completely agree. Thank you so much for that comment, Joel.
So I have two questions. First, I really enjoyed the presentation. It was well done. So I just was thinking about the gravity pods. You talked about that through the presentation. So I was thinking, okay, it looks wonderful. That would help to create some environment that is similar to Earth. But don't you think that getting on and off gravity pods would create some cycles that would have negative impact? I mean, because constantly there is no gravity, but there will be some cycles when they go in and out of the gravity pods. So what do you think? What's your comment on that?
That's a good point. When I was thinking about it, I was envisioning a lot of the work, like when I was talking to Dr. Pandya a lot too, she mentioned that a lot of the work that astronauts do, like they're in the aircraft like a lot of the time and they go out once in a while. But I think if we had gravity pods, and if that was like an individual thing or a room thing or a whole craft thing, it would allow the astronauts to get a break from the zero gravity environment, lessening up on the effects on their muscles, on their whatever else I talked about. And also, I think that that's a good point, though. I didn't really consider that part too much. And I think much more research, once something like this is in actual working mechanisms, will have to be done. Research will have to be done on that. But that's a really good consideration. It actually might have negative effects. So that's.
I was also thinking, because I don't have actually, a background of that, like you were talking about some mental health and how would be they isolated from Earth. What exists in terms of connections with Earth? Like when crew is out in the space, what kind of connections or what sort of connections do they have with Earth? I have no idea. That's why I'm asking. Like, do they have any sort of connections, or they are 100% isolated? They could not have any chance of any connection.
That's also a really good question. And I know that they do have access to ground control for sure from the space movies I've watched now, but they do have connection to ground control. And in terms of like social media and that sort of thing, I don't know how much connection they have with their families, but I do know that a few months ago when COVID first started, Chris Hadfield, who was on the very last slide, actually put out some sort of article or statement on, isolation. COVID is happening. I'm an astronaut. I have experience with that. So let me share some of my wisdom with you. So I don't know the extent to which they are subjugated to isolation from their families and from the rest of the world pretty much. But I do know that Chris Hadfield was trying to use some of his knowledge as an astronaut, being in those situations, to help others. So I think that was a really noble effort on his part. I hope that answered your question.
It's good. Fair enough. Thank you.
Thank you.
Yeah, of course, there's one other aspect of being in space for the long term that has quite a lot of things that we don't really completely understand. And that is, how can humans reproduce in space? What would pregnancy in space be like, and so on? And there there's just a lot of unknowns. You may feel that reproduction on Earth is pretty much worked out. There can be lots of problems even here on Earth. It's just an extra set of challenges. So that's another thing we will face.
Yeah, I agree. And when we talked about kind of reproduction rights on Shauna's PowerPoints as well, I think that whole